Seasons and the Sun. I can model and illustrate how the tilted Earth rotates on its axis, causing day and night, and revolves around the Sun, causing changes in seasons. For our starter, let's watch the video and explain how Earth's tilt and revolution around the Sun are responsible for the seasons. Explain summer, fall, winter, and spring in the Northern Hemisphere.
Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet Earth revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
Practice vocabulary. Elliptical orbit. An elliptical orbit is the path that Earth takes as it revolves around the sun. So Earth travels around an elliptical path around the sun. Kind of like an egg shape would be an elliptical orbit. Axis. An axis is an imaginary line that runs through both poles, the North Pole and the South Pole. Earth is tilted at a 23.5 degree angle. If Earth would not have seasons if it no longer tilted on its axis. Seasons: winter, spring, summer, and fall, caused by Earth's 23.4 degree tilt and revolution around the Earth. So the reason for season is the tilt as Earth does that revolution around the sun. Okay, and remember your seasons: winter, spring, summer, fall. Equator. An equator is an imaginary line around Earth dividing the northern hemisphere and the southern hemisphere. The equator receives the most direct sunlight, resulting in very little change in year-round temperature and hours of daylight. Near their poles, there are large changes in temperature. Most direct sunlight at the equator. Which of these locations on Earth experiences the least change in the number of daylight hours during the year? And of course, the equator receives the least change in number of daylight hours. Northern Hemisphere. The Northern Hemisphere is located above the equator. Earth's southern and northern hemispheres have opposite seasons. So if it's summer in the northern hemisphere, the southern hemisphere is having winter. And if it's winter in the southern hemisphere, the northern hemisphere is having summer. So the southern hemisphere is located below the equator. Winter. So when do we experience winter? Well, here's the equator, and we are in North America, which is in the northern hemisphere. When the northern hemisphere is tilted away from the sun, so look at your imaginary axis, you see how it is tilted away from the sun, we are experiencing winter. And since your seasons are opposite, it's the southern hemisphere that's tilted towards the summer, so they have summer. Spring. So neither the northern hemisphere or the southern hemisphere is tilted toward or away from the sun. So they're experiencing equal hours of day and night. Summer. So if we look here at Earth and look at that imaginary axis, the northern hemisphere is tilted towards the sun, so the northern hemisphere is experiencing summer. They're getting the most direct rays of the sun. The indirect rays are in the southern hemisphere, so they would be having winter. Autumn, which also means fall. In spring and autumn, neither hemisphere is tilted towards or away from the sun, so they are experiencing equal amounts of sunlight. Compare the hours of daylight at location X and Y. So if this is the sun, here's the Earth, here's your equator, we can say that location X, okay, is receiving more direct energy, so they're having longer hours of daylight and increased temperatures. When Earth is tilted away, like position Y, the sun receives indirect energy and less hours of daylight and decreased temperatures. For your activity and connection, we have a vocabulary assignment. We'll do this together. We are going to select and highlight one of the following seasons. So either winter or summer. We're going to draw it here in the box by drag and drop. So let me minimize, and let's just choose summer. So if I choose summer, okay, summer would have to be on this. And if we look here, the northern hemisphere where we are in North America is tilted towards the sun, so we would be having summer. Okay, if we wanted to have winter, what we would have is the northern hemisphere tilting away from the sun, so we would be in winter. So we would type that explanation here, that the hemisphere that's tilted towards the sun is experiencing summer. The hemisphere tilted away from the sun is experiencing winter. Okay, and a vocabulary review. For each term, rotation and revolution, we're going to categorize it by placing these words where they fit. So seasons. I would drag seasons underneath revolution, because revolution, it takes Earth 1 year to do a revolution around the sun, and we have seasons. Axis. Earth has an imaginary axis, and Earth rotates on that imaginary axis. It takes 24 hours. Spin is another word for rotation. 365 days. 365 days is 1 year, and that's how long it takes Earth to do a revolution around the sun. Orbit is another word for revolution, so I could drag that in there. Night, what causes day and night, would be underneath a rotation. Okay, and we also know that it takes Earth 24 hours to do one rotation on its axis, and a revolution takes 1 year. Based on the position of Earth, is city R experiencing day or night? Explain. So you know what causes day and night. The side of the Earth that faces the sun has day. The side of the Earth that's not facing the sun has night. So city R would be experiencing night. Based on the position of Earth, is city R experiencing summer or winter? So city R is in the northern hemisphere, and the northern hemisphere is tilted towards the sun, so city R is experiencing summer. And I can see that tilt by looking at that imaginary axis. If that axis is tilted towards the sun, it's summer. If that axis is tilted away from the sun, it's winter. All right, for your exercise today, you will only complete an exit question, and that's in Schoology. So that's all you have, and I hope that was helpful today.